Hello, my name is Aryan Garn, B19EE015. In this video, we are presenting our term project, which is an image classifier and is trained on Cifar-10 dataset. Firstly, we have imported all our necessary libraries like pandas and numpy. And there are a total of 10 classes present in our dataset. Then we have loaded our dataset and split it into training data, testing data, and validation data. Then we have normalized our pixel values between 0 to 1 by dividing them by 255. Also, we have converted our labels to one-hot encoded labels. Then we have seen that we have a total of 40,000 of training images, 10,000 validation images, and 10,000 testing images. And this function is used to plot the accuracy and loss curves for training and validation sets. Then we have built our convolutional neural network, which consists of convolutional 2D layers, activation function as ReLU, and some max pooling layers and dropout layers. And then we have also added dense layer, which consisting of 250 neurons, and this dense layer is used further to produce feature vectors which can be used to train different machine learning classifiers. Then after that we have using the Adam optimizer and compile our model. After compiling, we have used image data generator to produce more testing and training images. Then we have fit our model on 100 epochs and applying a batch size of 32. As we have seen that our training as our validation accuracy is 30% at the first epoch, which is increased to 78% after the 100 epoch. Then we have evaluated our model on testing data and seen that the accuracy of 78%. Also, we have plotted our accuracy and loss curves for training and validation sets. Then, as we have discussed earlier, we have used the above dense layer to produce more feature vectors for the machine learning classifiers.
Hello, my name is Ankit Chaudhary, B19EE011. After extracting feature vectors from CNN, now we will apply different classifiers. Firstly, extreme gradient boosting. Here, we can see the implementation used. Also, we can see the accuracy as 72.33%. Here is the confusion matrix and here is the classification report. Similarly, we will apply the same for random forest classifier. We can see that we get 72.31% as our accuracy. This is the confusion matrix and this is the classification report. Similarly, for nearest neighbor, we can see that 72.57 is our accuracy, and this is the confusion matrix and this is the classification report. After comparing all the classifiers, we get to know that the accuracy is highest for CNN, so we will save it. Now we will apply perform dimension reduction using PCA. Now we will apply standard scalar and normalization. Also, we will save our 95% of the data. Now we will see that we reduce our features from 500 to 80. Now we will apply the same ML classifiers to reduce dimensions. We get to know that the accuracy is 60.61, and this is the confusion matrix and this is the classification report. Now we'll apply 5-fold cross validation on all the above classifiers, and here we can see the accuracy.
Hello, my name is Anush Devkar, roll number B19CSC015. For the extra analysis of this project, we have plotted ROCOC curve for the best performing model, which is our random forest. Initially, we have imported all the necessary libraries, and then we have declared our variables. We have declared our classifier and trained them. Finally, we computed ROCOC area for each class, and then we have aggregated all the false positive rate. Finally, we have plotted the ROCOC curve using PLT function from matplotlib library, and hence we can see that we get the following ROCOC curve. Next, we performed hyperparameter tuning using Keras tuner for selecting the best performing convolution neural network. Initially, we have installed the Keras tuner, and then we have created a class of CNN hyper model which has a build function that actually takes different activation functions, different filter values, and different layer which vary between 32 to 64 to get the best accuracy. Finally, we have created our hyper model. Next, we performed a random search which will assign random values of accuracy of activation functions and filters in order to get the best results. Finally, we have splitted into training validation and testing set and converted the pixel values between 0 to 1. And finally, we have calculated the accuracy of our model. We get 74.75 accuracy, best validation accuracy.
In our project, we have also made a web GUI as an extra analysis, in which we can upload an image and classify it to 10 different classes. To test the GUI, we are uploading an image of a cat. So you can see that the predicted class given by our model is a cat. This web GUI is made through Django framework, and the GitHub link for the complete code is given in the PDF report.